let's start out with a problem to review and reinforce what we learned from last time. Let's try to get that focus going. There we go. Okay, so please take a moment and solve the equation using factoring. And I'll check it after a few moments. Okay, after giving you a little bit of time, the way I'd like to solve this, the way we learned how to solve this last time, was to say, look, what can we factor out from both terms? And from the first term, I'm seeing 5 times x. I'm seeing that in both terms because 15 is 5 times 3, and I'm seeing an x in both terms. So if I take 5 times x, that's going to be 5x times x minus 3 equals 0. So to recap, 5x times x, that's 5x squared, and 5x times negative 3, that's minus 15x. So I've been searching for, what we called the greatest common factor, that's 5 times x, that I can take out from both terms. And that's going to give me, well, it's going to, if I want to now solve that this is equal to 0, that means that one of the factors has to be 0. It's going to give me 5x equals 0, or x minus 3 equals 0. So that's going to tell me that either x equals 0 or x equals 3. So those are the two possibilities. So are there any questions or comments about that from last time? In order to bring us into what we're going to do this time, I'm going to start off with another practice problem. So I'm going to say, please take x plus p times x plus q. Please use the FOIL method to multiply this out. So I'll give you a moment to do that, and then we'll discuss and go forward. Okay, after giving you a few moments to work. After giving you a few moments to work and thanking you for sharing your answers if you did so. Foiling this out, what does it mean? The firsts are x times x, giving me x squared. The outside is x times q. The inside, that's p times x. And the last, that's p times q. And I actually like to simplify this. So I think there's one more step, which is x squared plus q plus p times x plus p times q. So why do we care about this? What we're going to do in today's lesson is we're going to do this process in reverse. That is to say, given some example, like let's look at x squared plus 10x plus 16. And the question that we're going to ask is, can you split this up into two factors? So can we factor it? What does it mean to factor something? It means take an expression like x squared plus 10x plus 16 and then rewrite it as x plus something times x plus something else. In other words, can I find p and q so that x squared plus 10x plus 16 is equal to x plus p times x plus q? And the key to doing this is to say, look, like in general, we multiplied this out and we found out that p times q is going to have to be 16. And we found out that p plus q, it's written q plus p there, but it's the same thing as p plus q. That's equal to 10. So I want numbers that multiply to 16 and add up to 10. And that's going to be the secret for how do you factor this equation. And so to help us organize that, I think it's a nice idea to have like a little chart. So here you can put your factors. Your factors of 16, and here you can put their sum. So you're searching for numbers that multiply to 16. Whenever you have two numbers that multiply to 16, those are called factors of 16. So you're looking for like what are the factors of 16? And you can kind of write them down in order, like 1 and 16. And then what's the next largest factor? You could do like 2 and 8. Or you could do 4 and 4. And that's going to be it. And so among these factors, which pair adds up to 10? That's what you ask yourself. And so these first two add up to 17. It's not helpful. The last two add up to 8. It's not helpful. But 2 and 8, that's Goldilocks, that's just right. That adds up to 10. So this is telling us that the answer is going to be x plus 2 times x plus 8. Because we know that in general, this calculation that you did for me says the last term has to be the product and the middle term has to be the sum. And that's just what we've arranged. The last term, 16, has to be the product of 2 and 8. And the middle term, 10, has to be the sum of 2 and 8. And just to recap, what's our way of finding that? We take this last term. What are the numbers that multiply to give me 16? In other words, what are the factors of 16? Write them out in a list. Just see which ones add up to your middle number. And you can check your work. If you FOIL this out, you'll get x squared plus 2 times x plus 8 times x plus 16. So it really does scan. It really does check out and work. So are there any questions or comments about that? Let me give you one to practice. Let's say, let's have you factor the polynomial x squared plus 7x plus 6. So I'll start out with making part of the chart for you. So what are the factors of 6? And what's their sum? So think that through. Which two factors of 6 add up to 7? And that'll help you solve the problem. So take a minute on that and let me know when you're finished. Okay, after giving you some time to think. What are those factors of 6? Well, I could take 1 times 6, just sort of starting from 1 and then going up. I mean, when I say factors of 6, I'm looking for the whole numbers that multiply out to 6. And then there's also 2 and 3. And 1 and 6 add up to 7, and 2 and 3 add up to 5. So that's telling me that I'm going to take x plus 1 and x plus 6. And when I FOIL that out, I'll get x squared plus x plus 6x plus 6, which will add up to x squared plus 7x plus 6. So you take your constant term, you look at the factors of that, try to figure out which ones add up to the middle term. There's other factors of 6 that we've been ignoring too, right? Like I could say minus 2, minus 3, minus 1, minus 6. Those are there as well, but these add up to -5 and -7. And since I knew that I wanted to add up to 7, and not -7. I ignored those for the time being. But it could be the case that like you need these, like if this number was negative, for instance, you might need the negative factors. So I'll start including those from now on. In fact, let's do another example where that's going to be maybe helpful. Let's take x squared minus 8x plus 12. And this time I'll give you a little bit less scaffolding. I'll just give you the problem and say factor the polynomial. But I will say in words that, excuse me, I will say in words that you'll need to find two numbers that multiply to 12 and add up to -8. So take a moment and work on that, and I'll check in. So after giving you some time to think, and thank you for sharing your responses, what we can do here, we're going to want two numbers that multiply out to 12 and add up to -8. So I can make my chart for what are the factors of 12, and then what's going to be their sum? So the factors of 12, I'm thinking 1 and 12. Then, like, increasing this number, I'm thinking 2 and 6. Then finally 3 and 4, and that's basically it, except they could also both be negative. So I could take like 1 and minus 12, and that'll still multiply out. Negative 1 times negative 12 is equal to 12. I could take minus 2 and minus 6. I could take minus 3 and minus 4. So those are my options. And I want to pick the two numbers that are going to add up for me to negative 8. Which means I can basically skip all the ones that are positive, like 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. Is there anything that adds up to negative 8? Negative 1 minus 12 is minus 13. Negative 2 minus 6 is minus 8. Minus 3 minus 4 is minus 7. So it looks like this is the one that we're interested in. So that's going to tell us that x squared minus 8x plus 12 is equal to x minus 2, x minus 6. And you can see when we FOIL that out, x squared, and then x times minus 6, x times minus 2, they have to add up to negative 8, and then the final negative 2 times negative 6, they have to multiply out to 12. So that's why we're searching for factors that multiply to 12 and add up to negative 8. Okay, so any questions or comments on that? Let's check in with our textbook briefly. See how that's being explained there. See if I can get this set up. Okay, let me know if you've got any issue seeing that. You can, this is page 386, by the way. It's chapter 7, section 5. It's be the last section we're doing this semester. And so you can see them doing this calculation like we did at the beginning of class. X plus p times x plus q is x squared plus p plus q times x plus p times q. Which is saying, like, when you want to reverse the process, like with x squared plus 6x plus 5, you need two numbers that multiply to 5 and add up to 6. So you can choose 1 and 5 as the two factors of 5. And they'll multiply out to 5 and add up to 6. So you can see them doing the first example that we looked at, x squared plus 10x plus 16. So you look at this constant term, you want to find out what are those factors, 1, 16, 2, 8, 4, and 4. You pick the two that add up to 10. And then you can write down x plus 2 times x plus 8, because you've got 2 and you've got 8 are those numbers that you picked. And this guarantees for you, since they multiply to 16 and add up to 10, when you FOIL it out, that'll be what you get. And here's the problem we just did. The same method's always going to work. You're always looking at the leftover term, the constant term, saying, what are the factors? Which ones add up to negative 8? And in this one, you want to pick -2 and -6, multiply to 12, and add up to -8. And we'll keep going on. We'll do a few more. I like this x squared plus 4x minus 21. Sure, the example is written out, and if you've got your book, you can keep looking at it, but I'll have us do that as an exercise to work on for our own. So let's say, get some better focus there. Always takes a while for this camera to focus. Oh well, not quite there. Sometimes it's hard for me to focus too. Can't blame the camera too much. Hope that won't bother you too much. So let's give you a minute. Please work on x squared plus 4x plus minus 21. So search for two numbers that multiply to -21 and add up to 4. And we'll check in a minute. Okay, after giving you some time to work, I'll work it out myself. Give this camera one more chance. Okay, there we go. I guess it needs to see my desk a little bit to focus up. So I'm searching for two numbers that multiply to -21 and add up to 4. Just go ahead and make my little chart. So what are the factors of -21? So I can certainly do 1 and 21, or -1 and 21, or 1 and -21. That will multiply to -21. Certainly not going to add up to 4. So let's try 3 and -7, or -3 and 7. Do either of those work? So 3 minus 7 is -4. -3 plus 7, that's equal to 4. So that's the winner. So that's going to tell me that x minus 3 times x plus 7 is going to be equal to x squared plus 4x minus 21. And indeed, when you factor it out, or use that FOIL method, so the first x squared, the outside's 7x, the inside -3x, adds up to 4x. And then finally, -3 times 7 is minus 21. So good stuff. And let's do some more practice. let us take y squared plus 13y minus 30. And please take a moment to factor that. Remember, you're searching for numbers that multiply to negative 30 and add up to 13. So take a moment, let me know when you're done, and I'll check in. Okay, after giving you some time to think, let's check it out. Focusing on this constant term, let's make our little chart. Factors of negative 30. I'm not, I guess I won't even write down 1 and negative 30 and negative 30 and 1 because of course those aren't going to add up to 13. So let's start a little bit bigger. You know, you what about 2? You can have 2 and 15 multiply to 30. 2 and 15 multiply to 30, so negative 2 and 15 multiply to negative 30. So 2 and negative 15 multiply to negative 30. You've also got 3 and negative 10 and negative 3 and positive 10. And there's more factors too, but let's just start checking sums and see what we've got. Negative 2 and 15 add up to 13. So I guess we're already finished. Once you found it, you found it. You don't have to keep on adding up the things that aren't going to work. Like 2 and negative 15 is minus 13, which won't work. 3 and negative 10 is minus 7, which won't work. And negative 3 and 10, of course, also, excuse me, that's plus 7. Negative 3 and 10 is plus 7, but it doesn't work. It's not equal to 13. This is the one that gives you 13. So I can say with confidence, it's going to be x minus 2 times x plus 15. And I can check my work by foiling that out. The first x squared, the outside 15x, the inside minus 2x. Adding, well, this is y squared plus 13y minus 30. So I don't know why I'm switching the variable to x. It's kind of silly. Y minus 2 times y plus 15. Excuse me for that. But you multiply it out. Y squared for the outside, y times 15 minus 2y is 13y. And then finally for the last, negative 2 times 15 is negative 30. So you can FOIL it out to check your work, but you know you're going to be right as soon as you pick two numbers that multiply to -30 and add up to 13. I'll show you a real world example. Been a while since we did one of those. I will take this from the book. So this is on page 388. Example 4, if you want to follow along, but I'll do the entire thing just on the paper. The idea behind this is you've got a square plot of land for your garden. Forgive me, I'm no great artist, but this is supposed to be a square. Let's call the side length S, that's unknown. And S is in meters, so it's real world problem, so we should specify the units. And you want to put a pumpkin patch in your garden. Why not? And you want enough pumpkins. So you've decided that you want to have like a 600 meters square. Pumpkin patch. And you need like 40 meters of space for the rest of your garden that way, and you need at least 30 meters of space for the rest of your garden that way. And then the question is, how big should you make the total side length of your garden? Like maybe you want to fence it in, so you're searching for like how big should you make the total side length of the square garden. So the question is, can we find the side length S? So given that we want to build a square garden with a 600 meter square rectangle, giving us 40 meters left over on one side and 30 meters left over on the other side. How big should we make the square? Might not seem like it, but this is an algebra problem, and we can solve it by finding the roots of a polynomial. Let's see how that can be done. The trick is to write a formula for the area of this rectangle up here. So the area of a rectangle is length times height. What's the length? I mean, the total side length is S. So if this part is 40, this part should be S minus 40, because these two lengths have to add up to be S, because it's a square. On the other hand, what's this length? If the total side is S, then this length must be S minus 30. Because again, 30 plus this length has to add up to S. So length times width is going to give me S minus 40 times S minus 30. So now we've got an equation for S, and we can think about like, how can we find S? And what I want to do is first FOIL this out. So this will be S squared, and the outside gives me minus 30 times S. The inside gives me minus 40 times S. And what about the lasts? Negative 40 times negative 30. It's 1200. And how could I do that so fast? Well, negative 4 times negative 3 is 12. And then you've got 10 times 10. which is 100. So 1200. So you get that 600 is s squared minus 30s minus 40s plus 1200. In other words, 600 is s squared minus 70 times s plus 1200, just adding that negative 30 and negative 40 together. So now what I want to do is subtract 600 from both sides. And that'll give me something equal to 0. Just taking away 600 from both sides gives me 0 equals s squared minus 70s plus 600. And so now you see what I mean, because you've got an equation for s where on one side you've got s squared minus 70s plus 600. On the other side, you've got 0. And if you can solve this, then you'll be able to find the side length. So in order to solve this, I need to factor the polynomial. So I need to find two numbers that multiply to 600 and add up to negative 70. And start looking at my table. So what's going to multiply to 600? Well, certainly 10 and 60. And that already adds up to 70. So I'm almost there. I want something to add up to negative 70, however, so I should pick negative 10 and negative 60. That'll add up to negative 70. So I can say that this is going to be s minus 10 times s minus 70. So I'm getting 0 equals s minus 10 times s minus 70. So what are the possible values for s? S equals 10 and s equals 70. So from a mathematics perspective, like both of these possibilities are valid, they both make the equation equal to 0. But only one of these answers will make sense in the context of the problem. And if you look back at the problem, s minus 40 and s minus 30, they need to be the lengths of this pumpkin patch, right? So s is going to have to be bigger than 40 in order for s minus 40 to make sense as a side length, which means I want to pick s equals 70 and exclude x equals 10. So this solves the equation, but not helpful because it cannot be a side length the way I've got the problem set up. Whereas s equals 70 does solve the equation and makes sense in the context of my problem. So I should choose a side to be 70 meters. And if I do that, I'll be able to have this nice garden with a 600 square meter patch for the pumpkins and all this space left over. I know that's kind of a tour de force of algebra, but it's also pretty cool. It's a nice application of all this stuff, isn't it? So that really concludes the course in terms of information that we've presented. I think you've all come a long way. I'm proud of you. But we still have 2 more days of class left. So tomorrow we'll do a review. I'll tell you exactly what's going to be on the final assessment. And on Wednesday, we'll just during the class period, we'll do the final assessment to see where we are. And I'll put some information about that on the Google Classroom as well. So thank you everybody for your time and attention. We've got 2 more days left, but still it's been a wonderful semester. And I'll see you tomorrow.